want to edit anything or something like this, you can do it. Right? You want to replace something here, you want to bring something here, you can do it. Otherwise, keep it default. Don't take much longer with it. Otherwise, now we will be largely using these two: data, transform, and analyze. These are very, very important. Define variable properties. We will see that how we define the variable properties. You can define the variable properties here, or you will be defining the properties in the variable view. Right? One and the same thing, you can do it here. You want to change the variable properties. Generally, we don't use this, but we directly go to the variable view and change it. Or whatever the properties the variable properties we want to define it here, we edit it here. Right? But the major things that we are going to use here are sometimes we use some merge files. Merge files. For example, you collected the data. You collected data separately. She collected it separately. You want to merge those data. Variables are same on the top. File A, file B. You can merge. So that data would be. If variables are separate, it will merge the variables. Put unique variables side by side and put the data. Right? So sometimes we use it. Add cases or add variables. Right? Both are there. Say if you are adding, you have collected data on 5 variables, she has collected data on 10 variables, but different 10 variables. So when you merge, you will be using add variables. In case cases are there, only cases are there, so then add cases and then. So 50 cases are there, 50 other cases are there, now total cases will be 100. So sometimes we use it.
So cases are basically responses.
Responses, yes, yes, yes. Okay. Split, sometimes we use split. Okay, we have to use it. We need to have data set for this. Split file. We use it, split file, copy data set. Say, we always say that when you enter the data, first data is your master data. When you are using the data for analysis, you must have a master copy and then you should have working copies. Your original data should be labeled as master data and saved. From there, you can make number of copies. Just simply, for example, this is a master data open. Just simply, you click on this, copy data set. A new copy is created. A new copy will be created. Copy data set. Although there is no data set, so there is no opening. Otherwise, it has shown the command that. Right. Because there is no data set, this is the output window. You can see that this is the output window. Right. Moment we will enter and then we will see that split file. Split file is used. Okay. Let us open it. I'm just opening any. Okay, just enter. I'm just entering one variable. Let it remain numeric and values are. I give 1, label 2. We'll come back to this. I'm just entering for male and label 2 for female. We'll do it just to show you. Now you can see that now it's working, right? Split File means you want outputs. Say for example, I want outputs separate for male and female.
So split by geography.
Split file here means we want to split the outputs with respect to certain variables. For example, if you look at compare groups, say I want to compare male and female. I simply enter it here, I select it and enter it here. It will give me the outputs separate for male and female. Separate for male and female. Organize outputs by groups. So it will organize it first male and then female, or first female then male. I have given code 1 to male, so first it will be male, second group comes later, it will be female. So it will put it like this, right? Or compare groups, side by side, right? Side by side. We will see that. I'll show you how side by side comparison. For example, mean age of male is 39 years, mean age of female is 32 years, right? So side by side it will be comparison. Standard deviation of male is say 3.2 years, female is 2.1 years, something like this, right? Cut-off is or something like this. So whatsoever is this? Say we are measuring loyalty, brand loyalty or something like this. Your purchase intention towards something. So purchase intention of male is like this, female is like this. So comparisons. Wherever you want to compare it, with respect to certain variables. So there can be more than two groups as well, more than two groups as well. There can be. Now in case of profession, so various professions are there. We have self-employed people, we have farmers, we have student group, we have working housewives are there, or retired people are there, or job employed are there. So you can compare. So it is used for that purpose. Select cases, very important. Select cases is used for sampling. For example, I want to withdraw 10% samples or 50% sample or 20% sample randomly out. See, when we do analysis, there is a concept of called results validation. We validate the result. How do we validate the result? One of the ways of validating the results is splitting the data into different proportions and then comparing it. Overall, say you have 500 data sets. So what are the results of 500 data sets? Then what you do is we split it into 25%, 50%. Then it will randomly pick 25%. Create a separate file of it. Data. Separate file of it. Now you run analysis on those 25% and compare the result of 500 with 25%. It is random. It tells you the consistency or validity of the data. Then you pick 50% out of it and then compare the results with the overall data and 25% and put represent it. It tells you that whether your results are consistent or not. Right? Because it is looking random. So there are various ways we can pick. If there is any condition, we put any condition. If it is a random sample, if it is based on time or case range or user file variable, whatever are there. For example, we generally use it for, say, you will be using very widely this. Approximately, say I say 25% of cases. So approximately 25% cases it will be. Maybe because sometimes odd cases, odd number of cases are there, 471 cases are there, so how will you do exactly 470, 25% of 475? So one plus minus could be there. So approximate would be there. Or exactly you can say I want, say your data set is 471 and you want 25% or 100 cases out of it, exactly 100 cases. So you will write exactly, click here, 100, 471, right? Or you want 100 out of first 200, that is also possible. Then from first 200 cases. So whatever you want to do, you can do it. So it helps you generate subsamples, right? Sometimes we need to generate subsamples. Now, if condition is satisfied, then If condition is satisfied, it means if your mean is greater than this. Select cases in case you apply certain mathematical formula that if mean is greater than 3, say you want to use only the cases where your mean is greater than 3. 3 means, say, it is on the scale of 5. 3 is a midpoint. 3 is a midpoint. 1, 2, 3, 4, 5. 1 and 2 on the negative side, 4 and 5 on the positive side, 3 is on the middle of it. So anything above 3, so you can apply mean greater than 3 or something like this. Any condition you want to apply, you can apply a condition. First case, last case. So 1971, the first case, 2000, last case. So if it is time series, right? But generally, this is most widely used. These are some special cases, but this is most widely used. And then what we do is copy the data set to this. What we do is we define the data set. Say it is first 25% or 25%. Yep, 25%. We give the data name and it will select the cases and put it. A new file will be created. You don't have to do anything. It will automatically do it. Vague cases. Sometimes what happens that it is very less used, but it is used. We will do it chi-square test and then we will see that where it is used. Then you will understand. We want to use certain variables and do analysis with respect to that variable without selecting that variable. Without selecting that variable, I select a variable here. That way that cases, say for example, gender, we'll do it in chi-square test, then you will understand better. Say there is no space to select the variable, otherwise we have to select the variable. But there are other variables which you select, but analysis of this variable is to be done. Right? So what you do is, you first tell that, look, way the case is this, but in the analysis, there is no option to select that variable. Right? So you have already advised the computer that when you are doing this analysis, you have to use this variable as an outcome variable and then analyze. Right? So we will see in chi-square test when we do it. Transform. Okay, what we do is, let us slowly, should we start entering the data so that, right? And then we will do it, right? Okay, see, we have entered the first, that is gender, right? Whenever we see a person, the first thing we see whether a person is male or female. When I look at you, the first thing I see is whether you are male or female, right? Second thing what I do is I look at the age. So second variable is age. Generally it is used. Please look at this one, I did not explain it earlier. See, your data has various forms. Your variable can be of various forms. It could be numeric, it could be comma, dot, scientific, date, dollar, custom currency, string. But generally what we do is, what is the meaning of numeric variable? It means when we are entering the data in the numeric form. When we are entering the data in the numeric form, we have to select data as numeric. Right? When we are entering the data in the dollar currency, we use it this. If it is a date variable, we use it this. If it is a date variable, then it will ask you which format is this. If it is a name variable,
Text.
name variable, for example, my name is something. My name is Amanpreet. So when I write the name Amanpreet, so it will be string variable, right? Or say I am entering city, so it is a string variable, right? So generally we use numeric variables, date variables, custom currency. Sometimes if it is rupees you want to enter or something like this, then you have to select currency from here. Otherwise you can enter dollar or something like this. So it is, we are entering the things in the form of numeric, so it is numeric variable. So this is nothing but the bits and decimal. Now in case of gender, it is either 1 or 2, so there is no gender. So if it is a continuous variable, for example, your currency rate is here. Today it is 86 rupees 50 pesos, so 86.50. So in that, if it is a continuous variable, then you use decimal as at 2 decimal place. Otherwise, there is no one. So here, what is the difference between name and label? See, name is a short form. Name is a short form. Sometimes we are not able to write the complete name, so it's a very short form. But here in labels, we write the complete name. For example, it's gender. Here it is, okay, gender we have written like this, age. Whether it is age group or it is age group or age in years or age as on last birthday. Now, if I'm asking you, what is your age? Right, maybe certain years, certain months, certain days, certain weeks. Generally, the right question is, should be, what was your age as on last birthday? Right? So we put it there. But it is a group. When I am asking you what is your age as on last birthday, then you would say, somebody will say 31, somebody will say 23, 24, 27, 28, 42, 53, 59. But if I ask you what is your age group, 40 to 30, 30 to 40, 40 to 50, 50 to 60, right? So when I am writing age group, it means that I am giving you a grouping variable. I am giving you a grouping variable. So we set the label. Right? So first, then we add it. It is activated. Right? 2. My second is 30 to 40 years. Now it is activated. Enter. Okay. Now, if I want to change, I can do. If I want to change anything, say I want to say write just 60 and above. I change it. Right? I have made modification. If I want to check the spelling, simply if I just click here, it will tell me whether there is any spelling error. If there is any spelling error, it will highlight it. Right? Income. Now, whether it's annual income or monthly income or family income. See, income can be my personal income. What question you are asking? Because what is the average question now? You may ask what is your monthly income. But what you are talking of individual monthly income or you are talking of family monthly income? You are talking of your income from your salary or collective income. I mean, sometimes people do have passive income as well. They do have some businesses running or something like this. Right? So your question must be very, very precise. And then if it is a group variable, then we say, what's the average here? Say, it's the annual income. So I say, something like this. Right? So it is a grouping variable. Right? So if I add here, it doesn't understand what is latch. Right? It is It doesn't understand up to. It understand? It doesn't understand up to. Up to. That's true. So it will suggest you what should be. Right? So you leave it. Ignore and lamp. It doesn't understand now. Right? It's an English, so it doesn't understand what is lamp and what is crores. Right? It understands millions and billions. So it doesn't understand this. So we can ask him to ignore it. Okay, that's fine. That is my term. Okay, that's fine. Right? Now I am going to enter certain variables which are continuous in nature. For example, if I ask you, okay, sorry. I am going to ask you, some brand is here. How do you rate a brand? I mean, now rating scale you have to see if you are satisfied or you are dissatisfied or you find it excellent or you find it worst. Right? What should be the rating? So it is a 5-point rating versus 7-point rating. Now if I ask you question. What is the probability you will buy Sony? What is the probability you will buy a Sony product? So now I can ask you this question in terms of highly uncertain to highly certain that I'll buy it. Or I can ask you what is the probability, you can say 3%, 5%, 10%, 50%, 20%, 30%, 80%. Right? So there are different ways I can ask you this question. So whichever the form you want to use, you can use it. So if I use it, say 20%, 30%, 50%, something like this. Now it is a scale variable. It is a scale variable. So no. It is a continuous variable, so I am writing a scale variable. You know different types. Have you heard studied this data types of data? Have you done types of data? What is the minimum nominal data, ordinal data, scale data? See, nominal data means we have categorical data, but there is no order in categories. All categories are equal. For example, male and female. So we say it is a nominal data. It is a nominal data. I will put it like a nominal data. A group. Now A group, whether it's a nominal or ordinal, there is an order in it. There is an order. Age group. Age groups are in order. 20 to 30, 30 to 40, 40 to 50. So there is an order. We know that in the second group, the people are more aged as compared to first group, and third group, the people are more aged as compared to group 1 and group 2, and so on. So there is a natural order that exists here. Right? So it is an ordinal variable. Of course, categories are here, but along with categories, certain natural order that also exists here. In nominal data, there is no order equal categories. For example, professions are there. All professions are equal. We don't say that which profession is superior to another profession. All professions are equal. They are all equally dignified. Right? So we have to say this. We have to identify that variable belongs to which kind of category, whether it's ordinal or whether it's a nominal. So it is an ordinal variable. Income is also an ordinal variable. Right? There exists, of course, people from earning more than 10 lakhs, they earn more than up to 5 lakh and 5 to 10 lakhs. Of course, there is an order there, right? So there is an order. But in scale, see, there are two things. One, measurement and scale. See, where do we use scale? Scale is a variable which is measured, not counted. One variable is counted, one variable is measured. Measure means we use certain instrument to measure it. For example, it's a weight scale, it's a volume scale. For example, we are measuring water in this. So it's a certain, we are using certain kind of scale. Universal phenomena, accepted phenomena, we are measuring and then giving it a number which is universally accepted. So it is a 1 liter. So this 1 liter is accepted here, so it's a universal accepted number given to the volume of this water. So it is a measurement that we are measuring it. Counting means we are counting how many males are there, how many females are there. Right? So one are integers, discrete numbers, one are continuous numbers. So wherever we have measured variable, we use it as scale. We use it as scale. That is very important. Right? Now, please enter the data. For example, we have very small data, then I'll send you data for the next workshop. But let us understand this, what is the meaning of this. For example, everybody please enter. For example, my first gender is A. We enter group. So first person, say I am the person and I belong to the age group 3 and my income is 3 or 2 and I say probably 20% probability is there, so I would say 0.2. 0.2 means 20%. Right? Then you enter somebody who's female, age group 1, income group 3 and say it has probability of 0.45% that you will buy. Then again a male is here which is age between this and this, income group this, and it has a 55% probability. And then there is another one, right? And so on. Now, if we click on this one, this A to 1, it means numeric to label. You want to see this? Oh, so if there are only 3 categories are there, so why is it? Just clicking on this, you can see that. Right? Now, we were talking of say, and similarly there are a lot of data. You can collect it, say copy it and paste it, say, just to make it more visible that okay, we have this kind of data. And then you can make certain changes here and there. Whatsoever is there, just I am making this spreadsheet so that we are able to see this. Right? So probably we will have a large sheet like this kind of data. Right? Now we can see that how many of them are male, how many of them are female. Now we will comment to this. Compute variable. What is the meaning of compute variable? Say, compute variable in the sense that we want to compute another variable from the existing variable. From the existing variable. For example, say I have 3 categories of income or 4 or 5 categories of age. I want to combine those categories. I say in my analysis, for example, I want to do okay, senior people and young people. So I say okay, above the age of 40 they are experienced, below the age of 40 they are less experienced. I create only 2 categories instead of having 5 categories. I want to make a distinction between experienced people and less experienced people. So what I do is I have to convert the data to 2 categories. I have to convert the data to 2 categories. Now I am not working with 5 categories. But originally it was 5 categories. But now I came to know that okay, it would be better if I convert the data to only 2 categories instead of having 5 categories. Put it into 2 categories. So how will I do it? How will I do it? Okay, redo into different variables. Oh, I will come to compute variable where it is used. It is used to apply the formula. I will apply the formula. Now, recode into different variable. Now we have one variable. There are two options. Recode into same variable or recode into different variables. If we say that recode into the same variable, it means the old variable will be replaced by the new variable. Old variable will not exist. Old variable will be replaced by new variable. But generally, what we do is we always say that recode into different variables. Okay, give it a new, create a new variable so that I do have previous information as well as new information. New created variables here. Although new variable will be created, we will be having previous variable as well. Right? So if I say age is here. See, we should always put this underscore whenever we are entering two words. SPSS does not accept space. It should be continuation. So when I am writing say age category, so between age and category there should not be any space. So we put underscore. So it would not accept. Okay, now you can say that add new name age to age category. You can see now new name is added to this, right? We actually earlier we selected the auto recode. We are not supposed to. So this is my okay. What should be the label? Age group, same, or we can say that seniority group. Seniority group or experience group, you can say whatsoever new name you want to give. So, we have 5 values here. We entered, if you remember, 1 up to 20 to 30, then 30 to 40, 40 to 50, 50 to 60, and 60 plus. Say I want to combine first two categories, 20 to 30 and 30 to 40. And then combine rest categories as 3 categories, right? So what I do is, range 1 to 2, add as 1. So what does mean by this? From 1 to 2, both are coded as 1, and 3 to 5, they are coded as 2. Add, continue, okay. A new variable. You can see. You can see a new variable is created, age category. Right? So you can see that age 3 is 2, 1 is 1, 3 is 2, 1 is 1, and so on. Right? So we can go to this variable, seniority group. No spelling error. Right? So what I have done is I have created a new variable from the existing variable. That is called redo. We have done redo. A new variable has been created and we use it very frequently. Many times we have to create new variables. Many times we have to do various computations and all this. So let's look at one. So again here, compute variable. So here we apply the mathematical formulas. For example, percentage is here. What is the probability? Say this is new variable is percentage. What I do is I select here, multiply, or you can choose a sign from here and then multiply by. So 20 is converted to 20%. Right? What we have done is nothing. So what we do is we apply certain complex formulas. I am just keeping it very simple. We will move to next class and then we will do certain complex things here. But just it is the first class. We are just entering the data first time. We are looking at it first time. So just keeping the things very simple. I mean, idea is that we can apply any kind of formulas here. We apply very complex formulas here.
Can you enter the data of income and how to use the data? Age and income in the value in the
Yeah.
how to use it.
See, okay, remove it. First is my age group is 20 to 30 years. And my first group is added 30 to 40 years. Third group is 40 to 50 years. Fourth group is 50 to 60 years. And my fifth group is 50 to 60 and above. ठीक है? अब इधर एक right? Okay. Now, if I want to convert rate, say I want to convert rate into different variables. For example, see how do companies tap us? If they find that your probability of buying something is more than 50%, then what does it mean by this? You are a potential customer. If the probability is more than 30%, then you are a potential customer. So every company has its own way of identifying their prospects. So in case probability is greater than 50%, so they will definitely tap you. Right? So if I am to convert this rate variable, probability variable, into high probability and non-probability customers, yeah, select or deselect variables, deselect respondents. I mean, what does it mean by this? We want to select you as a, we should approach you or not. Select or deselect. Should you be rejected or should you be selected for this campaign or sale campaign? How do we do this? So, reset. Okay, so that is my label. Old and new values. Say range or lowest room, say 0.5 and less. Now I am putting just lowest room is or below probability 0.5. They should be, which value should be given? So you can give a code here. This code could be 1, 2, 3, 0. Add here. All others or range above 0.50. जिन्होंने 50% के ऊपर है, they should be selected as 1, add, continue, okay. So you can see that we have two variables, 0 and 1. One. How many of them are rejected? How many of them are selected for this campaign? You can see. So what we have done is just obtaining the basic information. How we use that information? We are converting one information into second type of information. Continuous information we have converted to text information. A continuous variable, we can use continuous variable as now, so we'll be using continuous variable as well, right? But here we have converted in the summarized form that how many people are selected, how many are rejected, how many people should be focused. So we know that how many people should be focused, something like this. So idea is that there are n number of users. Every student will have a unique application. Every student will use this SPSS in a very different way, in a very unique way. Some of the common things would be there, like entering the data, recoding the data, coding the data, computation, some basic formulas and all this. But otherwise, when you do analysis, everybody will be doing the data analysis in a different way. Somebody might be using one-way ANOVA, somebody might be using two-way ANOVA, somebody might be using chi-square test, somebody might not be using chi-square test. Some people are using factor analysis, some people are using confirmatory factor analysis, something like this. Right? So depending upon the analysis or requirement of your study, you will be using different statistical procedures, but certain things are very common. Right? Okay. Automatic dummy variables. So what is the meaning of dummy variable? Dummy variable means what happens? Dummy variable is also kind of recoding. What happens? We use variables in the analysis in a different way. For example, in regression. In regression, what we do is say we have three categories: age group 1, 2, and 3. And I want to see the effect of age or age group on certain outcome. Your purchase behavior or your exposure to social networking sites, right? Or your probability to buy a product online, something like this. We do this kind of research. So most of you are from social sciences or engineering background. What actually you are social? Sorry, I forgot to ask you this question.
Social science.
Social sciences in the sense management.
Political science, sir.
Okay, political science. Okay. Psychology, so, this is a heart and core of psychology. For you, it is very, very important to learn the things. Anybody else from psychology? Okay. From management? Okay. From commerce? We are from commerce. And rest, you are from? Engineering. So you will be using it because experiment designs are there. So engineering will do a lot of experiments are there. Your man?
Law.
Okay, yours law.
Sociology.
Sociology is very well, they use it. Sociology is used.
Statistical economics.
Statistical economics. And what will you do with this? Econometrics?
Yes, economics and different
Okay, econometrics. So this is the building blocks. So you will be required to do a lot of econometric tools are also here. Yours? So music, okay. So I don't know. What is harmony of your occupation? So your management. Economics. Law. Yours commerce. Mathematics, okay. So many times mathematics, people from mathematics, they also force me to, organize workshop in their department. Law. Economics. Law. Law.
Okay.
All.
Report.
Okay.
Not post.
And agriculture. Very well.
नाम बताना है
Okay.
सर का नाम बताना
Forensic science. Agriculture is very widely used. Forensics is
today is only briefing about SPSS not आज सर इसने बताया सर ने लेआउट बताया SPSS
right. So, of course, see, for some of the faculties or for some of the disciplines, it might not be too relevant to correlate that directly because might be we are not directly going to use it. But economics department, sociology, and management department, they are very widely going to use it. Especially economics, and you are going to use parametrics. Right? Even if you are not going to use parametrics, generally you need data analysis. We do a lot of parametric analysis as well. Right? So anyhow, I'll be keeping the things very simple in very layman's language so that everybody is able to connect. So, dummy variables. Dummy variables are the categorical variables. Basically, we enter the data. For example, say if I have to enter age group, we have 5 age groups. We have 5 age groups, and if I enter 5 age groups in the data as a independent variable or as an influencer variable, that if I am measuring the effect of age on your exposure to internet or your internet usage or something like this, most common phenomena. Right? The time is spent on internet or something like this, social media sites. So it will give me one and only one coefficient. It will give me the effect of age. But I will not be able to know whether my age group 20 to 30 is different from 30 to 40, 30 to 40 is different from 40 to 50 or something like this. So what we do is that we convert the data into dummy variables. And instead of entering one variable, we enter multiple variables. We convert single variable into multiple variables and then we use them as input variables in the form of dummy. Dummy means 1 and 0. Okay, dummy means 1 and 0. Right? So 1, 2, 3, 4, 5. Okay. For example, A group has we have 5 age groups, right? Now, if I want to see the effect of A on certain variable, like as I said, maybe purchase or something like your likelihood to purchase or something like this. If I enter as a single variable in the sense that y is equal to a plus b into x. This is my A group. One variable. X is my one variable, y is my some outcome variable, my time spent on internet or something like this. So it will give me one coefficient. That will be representing the whole of the variable. But if we want to know the effect of individual group there, then if I want to measure the effect of A group 30 to 40, 40 to 50, 50 to 60, 60 to or 60 to above, then what happens? I have to convert this variable into dummy variables. How I am going to do this? Say I am going to convert. Now these 5 groups will be converted to 4 variables. K minus 1. K means the number of groups here, levels here. K minus 1 number of variables will be created. In the first, it will be 0, 1, 0, 0, 0. First variable. Second variable will be 0, 0, 1, 0, 0. Third variable will be 0, 0, 0, 1, 0, 0, 0, 0, 0, and 1. What is the meaning of 1? For this group, I will be putting the value of 1, all others as 0. For second group, I will be putting this value as 1, all others 0, as I said. Now, there are total 5 groups, 4 dummy variables will be created. This, now you can see that I have not used this variable. This is 1, 2, 3, 4. What about this? I have not used it as 1 anywhere. This is my reference variable with respect to which all other variables will be interpreted, compared. With respect to which all other variables will be compared. That if what is going to happen if my second group is here, how this is going to perform with respect to first group. My third group, how this is performing with respect to first group. My fourth group, how it is performing with respect to first group. My fifth group, how it is performing with respect to first group. So instead of entering one variable, I will be entering four variables in the analysis and estimating the effect of each variable. So that is more introspection into the analysis, more introspection into the data. I will be able to know more. I will be able to know the effect of each group, right? And then based on that, we can decide, or we can further interpret that which actually is the variable more relevant to this, right? This is how we do interpretation. This is the purpose of our data analysis and all this, to introspect deep into the relationships, right? So this is how to do this. If you want, I can show you how to take dummy variables. For example, say age group is here. So root is
So is there some type of test in this? If you do one variable testing with the results of the remaining four, there should be a type of a test which.
that is another. There is another test.
So this is the that will be teacher in the internet.
Yeah, this is one form of that test. What you are saying. Of course, what you are doing is absolutely right. That we are comparing it, but there are multiple ways. This is one way of doing it. There are other ways of also doing it. I'll show you when we do it. That what is the difference. Ultimately, those are also part of it. Right?
You increase the scope of the.
Yeah, of course. Don't worry.
थोड़ा सा इसको डमी वेरिएबल बोलता है we are assuming this 5 variable age group variable as dummy variable हमने डाल दिया 0 0 फर्स्ट में
बनाया कौन वेरिएबल
हाँ
बनाया किसी ने वेरिएबल
इसको क्यों बनाया इसको रेफरेंस करने के लिए एक को कंपेयर करने के लिए ग्रुप बनाने के लिए
Now you can see A group 1, 2, 3. Right? You can see 20 to 30, 30 to 40, 40 to 50. Actually, it has taken just 50 and 60 or something like this as, it has created 3 dummy variables based on the data. Might be some of the group might be missing there, so it has not included that group there, right? So you can see that it has created 3 dummy variables. It has created 3 dummy variables. It has taken, might have taken the highest value as the reference category, lowest as not lowest. Generally, you have to take either the highest value or lowest value as the reference category. So it is taking the highest value as the reference category. So you can see that these are the 3 dummy variables. So now if I have to use it as in analysis, I will be using, for example, say, I'm just giving, say this is my, and then I can use it here. So this is my output window, so you can see this. Right? So whether effect is significant or not or something like this, we will see what is the interpretation of it. But I'm just telling you that this is how do we enter it. Right? This is how do we use it. So I have used it, the information into the analysis, and then what we are seeing is whether the effect is significant or not. You can see that this effect is significant, this effect is not significant. Have you learned significance level? P values, what is the meaning of it? Have you learned it?
less than
Hmm? हाँ p values की है, critical values की है, table values की है, significance level and everything you have done. So you can read the result. What is the meaning of p value significance level?
You want it.
Right? You can understand the value of t. What is the meaning of t?
हम
What is the
देखा
meaning of this bit of standard error and all this basic understanding is here. So you can see age group 30 to 40, 40 to 50, its effect on something like this, probability to buy something. That is my dependent variable is what is the probability you will buy Sony? Right? So this is these are the two variables whose effect is here because data was like this. Right? So we will interpret it just today, but let us understand the environment only. So this is my output window, you can see that. Whatever operations we do, this is the script, commands, right? We can save it even. Right? Whatever the dummies we have created, see it has already created that this is regression. What is the command of regression? Right? You want to rerun it, you can rerun it. You copy it. Say you want to edit it, you edit it, and then copy it, and then you take it. Syntax, paste it there. दोबारा run it, same. Because you made some changes here in the command. Command is here. You don't have to run it everything. So you make the changes in the command, right, and then put it in the syntax. Run it. So it will run as per your requirement. You want to add something more here. Say for example, we copied it. You can see it. Say you want to write here something more, you can add it. You want to do certain special operations here. So these operations will be done. You add certain special operations here and then you run it, it will. You got it? So that is how we run syntax. Syntax is very important if you know something about programming. I am not a programming guy. So I may not be able to teach you how to write a program. But if somebody knows how to write a program, that is really helpful to them. Because they can do something, you don't have to repeat the things. You write one, command and you get everything out. Right? Okay. Now, this is where we will be spending our most of our time, analysis of window. Now you can see that, look, lots of analysis options are there. As I said, this is a trial, so they have given you all set ones, all modules are there. Right? Right from descriptive statistics to ROC curve. ROC curves are used, engineers must be using it in projects and all this. Efficiency curves are there. Right? So sometimes we also use it to know the efficiency of the data. Right? So you can see that descriptive statistics. First is the descriptive statistics. Frequency. The first is the frequency, the count. We need to count it. So you want to, right? Seniority. I simply click OK. How many males are there? 8 male, 8 female. 50% male, 50% female. 20 to 30, 30 to 40, 40 to 50, these are there. So that is why only two, dummy variables there have been entered into the regression because only 3 groups are there. So it will create only the 3 dummy variables, right? Right. So these are my income groups up to 10 lakh, 5 to 10 lakh, and above 10 lakhs. We entered only 2, right? And how many are there? Less experience and how many are experienced. Right? So, this is how we do. And even if you simply click like this, that is something like this, you will get the same thing. Right? How many are selected, how many are rejected. So, if you select multiple variables and simply add the right descriptive, it will give you something like this. Right? So you don't have to come to this command window, analysis command window or something. You can directly do it here. Right? So in descriptive statistics, next is the descriptive. Descriptive is used for continuous data. Frequencies are used for categorical data, ordinal data and nominal data. Frequencies, this count variables. Descriptive statistics is used for continuous data. Right? Now we enter. Right? What options we have? We can find mean, standard deviation, minima, maxima. So sometimes we look at the distribution of the data, kurtosis and skewness as well. So you can look at the kurtosis, you can look at the skewness. You want to see the range, right? Or you want to standard error or something like this. So minimum is the 20% probability we have entered. If you remember the data, maximum is 75% probability we entered. Mean probability is 0.4875. 48 around 49% is the mean, right? And this is the skewness of minus, and this is the kurtosis. So it tells us about the distribution of the data. You want to see further distribution like histogram or something like this, you can do it. You can go to explore like this. You want to see statistics. You want to see the outliers. Do you know what are the outliers? What is the meaning of outliers and what is the role of outliers?
Those data does not exist in the real life.
No, those who do not exist in the.
It's mostly like global distribution the data is set of medium. But the rest of the data is
Pardon? Okay. So let us refine our understanding of what are the outliers. See, outliers are the variables which may not belong to the data. Either they are too small or they are too large that they do not belong to the data set. Their presence might influence the results or they may even sometimes skew the results. Right? Now there are two types of outliers. One is influential cases and one is outliers. See, you need to understand. See, we have very scarce data. Data is not easily available to us. We collect the data with a lot of hard work. So we cannot afford to waste the data. So there should be a very clear understanding whether this is a truly an outlier or not. If it is a true outlier, then it should be removed. If it is just an influential case, it might have a minor impact, a minor influence on our results, then it should not be removed. Because trust me, data is very scarce. You want actually, you ask me, we collect the data from when we collect primary data, take a lot of years and years to collect the data. We have just signed a data for publication paper that the data was collected in 22. We are 25. In between, we wrote the paper, sent the paper in 2024, twice we got rejected. Now, third time it's being submitted. So data is not easy. You need to be very careful about it. Right? So we look at the outliers and plots. You want to see the histogram or stem and leaf, one and the same thing, but histogram generally we follow. Right? Normality plots, whether the data is normally distributed or not. So normality plot with a test. So it gives us a test value as well. So something is there, it is plotted here. But sometimes our misjudgment may be there looking at the plot, depending on the data. So it gives you the practically a test value here. Right? Okay, leave it. So you can see this is a mean value we have already seen. So 95% confidence level. Confidence interval, I believe you already know what is the meaning of 95% confidence. So it's a trimmed mean. Trimmed mean means removing 5% top and bottom values, right? Because if there are inferential values, they will fall either in the lower side or on the upper side. So remove those values and then you look at the mean value. Right? So median is here, variance is there, standard deviation is here, skewness, kurtosis is here. Look at this way. Test of normality. So for test of normality, we have two tests. So there are two tests for test of normalities. Problem Smirnov and Spirovic test. In econometrics, we generally do Jaffe-Berra test. In economics, we don't use these tests. In economics, we do JV test or Jaffe-Berra test. One and the same thing, right? Rather, computation of Jaffe-Berra test is comparatively easy, right? So you can see that this value is. What is this? What it tells me? These two tests. Can you tell me? Look at the test results and let me know how do you interpret it. See, this case test, Kolmogorov-Smirnov test, significance level is 0.192, and it is not significant. Here the value is 0.023. It is significant. Two contradicting results are there. Two tests giving contradictory results. The data. Right? So, Kolmogorov-Smirnov test says there is normality. It says the normality is intact. But Smirnov test says that normality is not there. Now, which test should you use? See, practically it is said that for small samples, this is more reliable as compared to this test. For large sample, this test is more reliable as compared to this test. For very large samples, none of them is reliable. You got it? For very large sample, none of them is reliable. For small sample, we can refer KSS, Kolmogorov-Smirnov test, which says that normality is here. But remember one thing, we should never rely on a single observation. Right? For example, here we have a critical case, a very classical case where two different tests are giving you different decisions. Right? So if you have to interpret these results, you have to, if you want to prove in your thesis, you are writing a thesis or you are writing a paper or something like this, you are presenting the result somewhere, you have to convince the audience what actually are the correct decisions. So you use the third test. Something else you have to use, and if it says wherever direction it goes, you will go by that result. Right? Now, look at this. How will you call it? See, ideally, all the data points should be on this line. If data points are not on this line, it means data is skewed. And we can see that out of 4, 3 points are off view. They are not on. So it means there is a problem. So data is a bit skewed. Not highly skewed, but small skewness is there in the data. Right? So data is skewed on negative side of it and positive side of it. Right? So small skewness is there in the data. So we will say that data does not meet the requirement of normality. Small problems. Right? So we have to look at not single result but multiple results to compute. Right? Sometimes their results will say different thing and this will say entirely different story. So visually we go by this. Right? So many times we have to go by, we get this kind of contradictory results. Right? Any questions from your side, please? Any questions? See, today just we have what we have done is only data entry. Now my request to all you will be, please do some practice on this. download any data from internet, you can do it. I'll send of course a mail to your coordinator and she will give you the data. But in the meantime, you can do some practice. You can download any Excel file, Excel data on mutual fund, on a lot of industry data is there, on stock market data is there, which is on internet. Download it, start entering the data, start learning the data, so that when we meet in the next class, we directly will jump. We will be starting where we are leaving today, from the discovery. Right? Then we will be starting in certain graphical presentations, and then we will move on to slowly the basic test, t-test, chi-square test, and what are the theories of it. Right? So that, but that time, by that time you should be familiar with what we have done. Right? Any queries you have, you can ask me in the first or next time whenever we meet. But do some practice. I think today's session was very simple, basic session. So everybody must be comfortable by now. Any questions from your side?
Any question from your side? Thank you, sir, for the good session. And on the behalf of this capacity building, Madam Harmanjot will give the vote of thanks.
Good morning, everyone. I would like to express our sincere gratitude to our well-known guest, Dr. Amanpreet Singh, for gracing us with your presence and sharing your valuable insights. Your words have been truly inspiring, and we are thankful to you. Thank you very much.
Thank you. Thank you very much. We will meet on the next session. Right?
Hope, sir, hopefully every participant have taken the basic knowledge regarding the SPSS. Thank you, sir.